once the set is defined, let us see what is Cartesian product of sets. Now this is a operation which involves two sets. When A and B are two sets, then the product A cross B is defined as collection of all order pair elements AB. Now when I say order pair, what is the ordering defined in this collection? It's a collection where the first element is coming from the first set A in the product and the second element is coming from the second set in the product. So if I consider a small example where A is taken as two elements 1, 2 and I take B as a set consisting of A, B and C. Now when I say I wanted to write A cross B, how will be the elements in this collection? It will be a collection of order pairs where the first element in this order pair is from 1, that is from A, and the second elements come from the set B, that is A, 1, A, 1, B, 1, C. Look at all the three order pairs. My first element is selected from set A and the second element is selected from the set B. There are still more collections, that is 2, A and then 2, B and then 2, C. See, all these elements are collected in such a way that the first element is selected from the first set A and the second element is selected from the second set B. Then this collection is called A cross B. Just for practice, can we also write what is B cross A in that? Now here what should be the difference? The first element should be selected from the set B and the second element should be selected from the set A. How will be the elements? Now my first element should be from B, that is A, 1, A, 2. B, 1, B, 2, C, 1 and C2. See all the elements. My first element is selected from the first set in the product and second element is selected from the second set in the product. Let us see the Cartesian product's one more property. If my first set A has P elements and the second set B has Q elements, then the number of elements in A cross B will be P into Q. As you see here, A has 2 elements and B has 3 elements, then my A cross B has 1, 2, 3, 4, 5, 6 elements in it. Now the reason is also very simple. When my A has 2 elements and my B set has 3 elements available in it, then each of these elements can be mapped to one element of B. Similarly, the second element can also be mapped to these 3. Therefore, that will result in 6 collections of order pairs, right? That's what is the logic behind this. Now, if you look at again the same example which I considered, A cross B has order pairs 1, A, 1B, 1C, 2A, 2B and 2C, which are not the same as that of my elements of B cross A. In B cross A, my first element is from B set and the second element is from A set. So that's why A cross B will not be equal to B cross A unless A is B. That is, if A and B are different, then the elements of A cross B will not be same as the elements of B cross A, right?